All right, welcome. This is 5D test review answers. So let's get started. So we have the first one. We are changing to radical form. Radical form. So we have to figure out what is being raised to the exponent, exponential. The exponent is 1/4, and here is just the n. Just the n. The 2 is not. If the 2 is involved, there'd be parentheses around the 2n. So the 2 stays on the outside, and we're going to have the radical, the denominator of the exponent is your radical, so it's a 4th root, or it's called the index, and then is n. If you want to put that to the first power, you're more than welcome to. On number 17, the 3x is being raised to the 7/4, so again it's a 4th root because that 4 did the denominator of the exponent, and it's 3x. And we're going to keep that in parentheses because all of that is being raised to the 7th power. All right, now with the next part, we have to go back to exponential form from radical form. So it's anything that's underneath the square, the radical, keep it in parentheses. So 5x is to the 8th power, so 8 over, and so index of 3, radical 3, cube root. Next one, number 19. We got to be a little careful here. So what is being raised to the 5th power? The 8 is, that's what the parentheses are, so it's 8 to the 5th power. And it's also the a. A is also being raised to the 5th power. So it's the 5th power, and it's a square root, so over 2. So this would be exponential form here. If you want to do 8 to the 5th power, you certainly can. All right, number 20, we have -2 4th root of 16 h to the 12 j to the 5th k. Let's simplify. We have 4th root of 16 is 4 2's. So that's going to come out. So it's a -2 on the outside times 2 is -4. And it's h to the 3, j to the 5/4, and k to the 1/4. So we have to figure out which ones must select all that are correct. So we have, is there one that looks like this? H, J, well, this one here, top middle. Oh no, it's not because it's -8. I don't see one that looks exactly like this, so it must not be exponential form. So let's simplify this. So we have from here, it would have been -4 h to the 12 over 4, or let's go the other way. It's just simplifying from radical form. There are 12h is h to the 12th, divided by 4 is h to the 3rd. J, we can make out one group, and k we have nothing. So we have a j left and a k. Is there one that looks like this? And for jk. Oh yeah, I forgot about the 4th root. Yep, this one up here. Definitely on a test, we would have to be careful with if there's another one that looks like this. So there should be one, but I think it made a mistake. All right, next one. Right in simplest form. So I see on the outside raised to the, everything in parentheses being raised to the -1/3. So that is going to be the same thing as 1 over 27 a to the 9th b to the -12th raised to the +1/3. At this point, you can simplify in exponential form, but much easier. We've worked a lot harder on radical form, so I'm changing it to radical form. We could raise this to the 1st power, but that's not really going to change anything, so I'm going to take it off. Now we're going to simplify this. We have cube root of 27 is 3. You can break it down with the trees if you'd like, but it's 3. A to the 9th, there are 9 a's, cube root, so 3 groups. B to the -12, there are 12, so it's 4 groups, so it's -4. I'm going to move that up to the numerator to make it a +4 as an exponent. 3a to the 3rd. Let's see what one that one is. So let's b to the 4th, 3a to the 3rd. There we go, D. All right, on the back, we have radicals. We are solving. So the first step is to isolate the radical. So we got to get the radical by itself. So we got to subtract 9, you get 7. We're now going to undo the radical by squaring. And that equals 49. We times by 4, and I believe that is 196. We do not have to check it unless you want, unless you have a quadratic somewhere in the problem. Number 23, we are isolating the radical. It already was isolated. This becomes x squared. You can put it in parentheses if you like, but it's not needed in this case. Square root and square, simplify. I see an x squared and it's positive, so I'm going to move all the terms to one side. So I have an x squared plus x minus 20 equals 0. At this point you can factor, use the quadratic formula, or you can graph. I'm going to factor. So a is 1, so I'm going to do what two numbers multiply to c that add up to b. And that would be a positive 5 and a negative 4. They multiply to c, they add up to b. So x plus 5, x minus 4. And set them both equal to 0, solve. You get x equals negative 5, x equals positive 4, and because we had a quadratic, because of this quadratic, we have to check. So we have to check our solutions. So the check is going to be done with from the original problem. So x equals negative 5. We're going to put negative 5 into the original problem, the original thing we started with. So it's negative 5 equals square root of 25. Negative 5 equals 5. No, it does not. So negative 5 is not an answer. It's an extraneous answer. Mathematically we got it, but when we checked it, it was not right. Let's check 4. Square root of 16 is 4. That's good. All right, so x equals 4 is our only solution. All right, number 24. Radical is isolated already, so we are not going to, don't have to isolate anything. We're going to square it. It's undoing a square root. And square root and square, 3 minus 6p. All right, p minus 2 squared means p minus 2 times p minus 2. So we're going to multiply that out. You can do it with the Punnett square, or multiply p times p is p squared. P times negative 2 is negative 2p. Negative 2 times p is negative 2p. And negative 2 times negative 2 is positive 4. P squared is positive, so we need to move all the terms to that side. So gather all of our like terms. 0 equals p squared. That is going to equal positive 2p plus 1. Now my a term is 1, so we do what two numbers multiply to c that add up to b, and that would be 1. 1 times 1 is 1. 1 plus 1 is 2. So we have our quick factoring is p plus 1 and p plus 1. That's going to equal 0. Set each factor equal to 0. Well, they're both the exact same factor, so you only set 1. Solve for it, you get negative 1. We still have to check because we got the quadratic at the very beginning, where we are solving a quadratic. So let's check this. So when p equals negative 1, go back to the original problem before we did any kind of solving. 6 times negative 1 minus 2. So that's 9, negative 3. 3 equals negative 3. No, it doesn't. So that is not right. Well, we don't have another solution. So this is actually the solution to this problem, as there isn't one. So there's actually no solution to this problem. And 25, so we have to solve this. So the radical is isolated already, so we undo the radical by cubing. We have 1/4 x plus 3 equals 8. We subtract 3. 1/4 x equals 5. Undo the fraction, you multiply by the reciprocal. You get x equals 20. Because we didn't have a quadratic at all, we don't have to check. Number 26. I'm going to subtract 7 first to isolate. I know it's an exponential form, but it's still an exponential form and radical form can be interchanged. And that's what I'm going to do now. I'm going to interchange it. So it's a cube root. 7v plus 2, keep it in parentheses, equals 5. Now, the radical is isolated, so we can cube it and cube. Certainly could have done that up at this step here. You could have cubed and cubed. It's the exact same thing. Exponent to exponent, you multiply. So you could have done that there and skipped the radical step. So looking at what we got left, we have 7v plus 2 equals 125. Subtract 2, make your middle school teacher, Algebra 1 teacher, or 8th grade teacher, whichever, proud that you can solve these problems. Divide by 7, divide by 7, and we get v to equal 123 divided by 7. I don't believe that's 53, so now I don't think it actually can simplify any further than that. And there's your answer. All right, come with any questions you have.